And then for the next couple of hours, the floor is yours, David, for the Climate Reality Project.
Thanks.
I'm looking very much forward to it.
Me too. Thanks, Mark. Thanks for inviting me. Yeah, we've been trying to arrange this thing for a while. So, my name is. Let's get this up here. So, there we go. My name is David Miller. I'm a presenter for the Climate Reality Project. I'm from New Jersey in the United States. Anyone from the United States? Anyone from New Jersey? And I've been living here for 32 years. And I'm a strategic communications consultant. And I work a lot within the area of the climate crisis. So communications with that. I worked on a large project for Vestas, the wind turbine manufacturer, large campaign last year. And so it's things like that I'm working on. So let's get started here. Can you all read in the back? Everything okay? You can see it? Okay, Kurt Vonnegut, who died a few years ago, American author. He is also concerned about what was happening with the climate and nuclear weapons. Those are the two issues that he was concerned about. So, this is taken in June 2010 in Nashville, Tennessee. This is the training for showing this presentation. And the presentation gets updated. So do you know about An Inconvenient Truth? Several years ago, Al Gore. That was Al Gore's first presentation. It's called different things now. But he realized that he can't just go around and show it to everybody. So he trained, I think we're up for about over 5,000 people worldwide who are now trained to go and do what I'm doing right now. It's all volunteer. We don't get paid to do this. And there are just all different types of people doing this. Academics, teachers, firemen, etc. So it's just everybody who's kind of interested in this, and you go around either to a university or a school or a club or wherever. So this is about 3 days of training here, and this was taken in actually during COP15, the climate conference in 2009. Al Gore was here. That's my fiancée. She's from Chicago. Lives in Stockholm. Actually going tomorrow to visit her. It's her birthday. She's also trained in showing this presentation. So this is the reason I do this. These are my daughters. This picture was taken, Rebecca here. This is her graduation cap from gymnasium or high school here. And this was taken about 5 days before I went to Nashville for the presentation, for learning how to present this. And this is Sarah, and I just actually came back last week. I came back from a 2-week trip to the United States where they're looking at colleges. She goes to a gymnasium now, and she'll most likely go to a college in the United States. Rebecca goes to Barnard College, which is part of Columbia University in New York. So, this is a picture of Neil Armstrong, first man to set foot on the moon. And this was taken a few years before the Apollo 11 mission. And there's a reason I'm showing this. This plane here it's a rocket plane called the X-15. It's still the fastest fixed-wing aircraft in the world. Now, what's this have to do with climate? Very little. But I want to show you a video clip here, and I'll explain it. There is a reason I'm showing this. It's going to be a few minutes long, and it's with Scott Crossfield, who was the original test pilot on the plane. And what you're going to see here is a video clip of the last ground test. So what they do is they take the plane, they bolt it to the ground, and they fire the rockets, they test that everything's okay. And this is the last test before they're going to, what they did is they strapped it under the wing of an airplane. It was a B-52 bomber, which is, whatever, and they dropped it in the air, very high up in the air, and then it shot up into space. So this plane actually went into space. So when it went to the very edge of space, so the pilots who flew this, and they're really flying it, they were astronauts. Okay, so you probably never heard of this. And the thing about this plane is that it ran out of fuel and glided back down, and it provided the basis for the space shuttle, which also does that, right? It just lands without any power and any fuel. So this was back in around. This clip you're going to see now is from about I think 1959. Let's see if we've got any sound on this. Can we turn this up a little? I'll stop this a second. Let's go back. Is it me?
You know, a lot of these developments are such, you run into trouble and all of a sudden things begin working. We were on that curve. The last engine run before the first flight of the big engine, I was in the cockpit. This was just a ground run, so I was just in a white shirt and my business suit pants. And sitting in the airplane running the darn thing. It's just like being in the sun. Everything around me was orange. I stayed in there because I had a good idea that being in that steel X-15 with all that fire around me was probably I was better off than trying to get out. And here comes an Air Force fuel truck with water coming out of it like Niagara Falls. And in the bottom of that waterfall was a guy named Art Simone, one of our mechanics. I still kind of choke up because he was coming through that fire to look after me, and I was better off than he was by far. I was in this big steel. He came up and got to the airplane. Of course, I couldn't wave him away because of all that bright shining on the windshield. He didn't know whether I was alive or dead. And he would try to open the canopy, and every time he put his hands on the fuselage, he'd jerk them away. I could see his flesh searing. He just didn't have the power against his reflex action to keep his hands on there long enough. I didn't want to crawl across that hot fuselage, and so I just jumped out. And I landed, I didn't wait for anything. So the canopy came open, I jumped out and I landed on him, and we got out of there. And nobody really was injured in that whole thing, fortunately. Him or me, his hands were burned, but not really as bad as I thought. He just didn't have his hands on there long enough to make a very serious burn. I went in the office right after that, and before we could even tell the company that a $50 million airplane was spread all over the landscape, the media started calling. They have good pipelines. I told them, relax. The only casualty was the press of my trousers. The fireman got me all wet when I jumped out of the airplane. And then I winced when I knew what I'd given the baptist, because sure enough, that old story, East Coast newspaper comes out with X-15, blows up pilot wet's pants. Didn't catch your attention, I'll tell you that. You're not scared. You're too busy wondering, hey, there's got to be a hole out of this thing. There's got to be a door. That seems to be the nature of people like me. They're always trying to figure out where's my back door. And frankly, after it was all over, it just damn ticked off that you lost a good airplane.
So, the reason I show you this clip is that my father, who's turning 82 on Monday, which is Earth Day, by the way, he was the project manager for the rocket engine. So there's one company building the rocket engine, and then the company North American was the primary contractor, in other words, built the plane itself. But they got this company called Reaction Motors to build the engine. He was a project manager on that, and the thing blows up. So his job was to figure out what happened with that. Now, in 1976, the Air and Space Museum opened in Washington. This picture is taken from a couple years ago. You come into the main hall, and this is the Apollo 11 capsule, the one that Neil Armstrong and Buzz Aldrin and Mike Collins came back in. This is the Spirit of St. Louis that Charles Lindbergh flew across alone, solo over the Atlantic Ocean. This is the Bell X-1, the first plane. It was Chuck Yeager who flew it to break the sound barrier You walk into this room, and back in the day, they even behind here, but down below, when you walk in, the Wright brothers, the very first plane was hanging there. Now it's upstairs. But that was back in the day. And it had just opened a couple of weeks earlier. And I walk in with my dad, and he looks up to the left, and he goes like this. I said, what is it? He says, I never saw the whole thing built before. Because he only saw the engine. And when he tested the engine, it was only the engine. He never saw the entire... That was out in California. He was on the East Coast. But it was out in California where they were testing the plane. So he had to fix this thing. So it turns out, they do the engine, and they have a little pipe for the fuel to go in the engine. But North American, they build the fuel tanks and a pipe going this way, and those two pipes have to join. Right? Now, to join the pipes, they use a flange. If you know what a flange is, right? This kind of disc, two discs here. They bolt them together, and that way you have the pipe going through. Now, this is super cooled liquid, right? This is like liquid oxygen, liquid nitrogen, etc. Very, very cold. And my father said the problem was, when they put the flange together, they put the bolts on the outside of the flange. Now, when you get the pressure building up, you can see it starts spreading in the kind of the middle here, and the gas was leaking out, and that's what exploded. So my father had to come up with a solution for this. And what he did was, he took the flange, he kept the bolts on the outside, he put extra bolts on the inside of the ring, he put struts to push the flanges closer together, and then he insisted to coat both sides, the insides of the flange, with 24 karat solid gold. About $200 worth of gold. This is a $50 million plane at the time. $200 worth of gold. And the managers refused. They said no. They said gold is for jewelry. Well, back then, we didn't really use gold for electronic. We use gold all the time now. I mean, you know, on weapons, everything. And probably your smartphone has a lot of gold in it and everything. So back in the day, they didn't use gold. And he insisted. And the reason is, gold is a very soft metal, and it turns out it doesn't become brittle when it's very, very cold. It remains soft. So if there should be any nicks inside, anything that's not smooth inside, it would fill out the little crevices so no gases could escape. But he insisted. And he tells me the story. And they coated it with gold. And put it back together. They built several of these planes. I think they repaired that plane that blew up. And so I asked my dad, so what happened? And he said, it never blew up again. So, there's a reason for this. I grew up in a family of engineers. My father's an engineer, an inventor. My uncle's an engineer. My brother's an engineer. My cousin's an engineer. And I believe that if there's a problem, you can fix it. Okay? So one of the reasons why I'm so passionate about the issues surrounding the climate crisis is I believe it can be fixed. I don't believe we've been focusing on the things that will fix it, but I do see some stuff coming up that I do believe will fix it or certainly make a big dent in what's going on. And that's what this presentation is about. I want to give you a little bit of background story about things that seem impossible. When you saw that thing explode, how do you fix that thing? But there are solutions, and sometimes the solutions are simple, like using gold, where other people wouldn't think of it. Okay, so let's get back to the presentation here. This is the first time that, now, I'm looking at the average age of this audience, or not the average age, but the majority age in this audience, and I bet you all grew up with seeing photographs of the Earth, right? But when I grew up, because I'm 53, so I was born in 1960, you saw globes, you saw drawings of the Earth. There were no photographs. There were barely satellites, and there certainly weren't satellites taking high-definition color photos that could stitch together and make a nice picture of the globe. So you're used to seeing this, but actually, I'm not. And there are probably a couple other people in the audience that grew up not seeing this. So what this is Apollo 8. This is around Christmas of 1968, and as they circled the moon, this photo is called Earthrise. You know about moonrise and sunrise? Well, this is the first time that humans saw the Earth rising. And they actually read from Genesis in the Bible about how God had created the heavens and the earth, because it was Christmas. So it was very appropriate. They were looking out the window, the camera was pointed out there, and I remember I was on vacation in Miami or something, watching on a black and white TV in the hotel room and everything. So that was pretty cool. I'm really into space, by the way. We have a lot of space in our family. Space-related stuff. Okay, so this is the last Apollo mission. This is Apollo 17, and as they were going to the moon, basically the sun was right in front of them, and when they turned the capsule around, this is the very first time that humans have seen the Earth whole. The blue marble. Okay? Because the sun was right behind them, because normally you see part of the sun, you know, if we go back to this picture, you'll see that Earth isn't whole here. But this is the very first time. And this was published, I remember, in National Geographic. They made a big poster, and I had it hanging in my room. And it was just about this time, actually, that Earth Day started. You see, what happened was, we became aware that this is all we got. And there were issues with pollution. There was a river in Ohio, I believe. It caught fire. The river was on fire because of all the pollution in it. It was actually burning for a couple of days, which was like a really bizarre thing. Why should a river be on fire? But it was. And we were killing the birds with DDT, etc., etc. So there was this environmental movement. But as soon as we saw, like seeing is believing, right? There's, well, I could get a little bit into cognitive linguistics, but how we understand things and language. And there's this professor at Berkeley, in California, UC Berkeley, George Lakoff. But basically, we understand things through our bodies and our experience. That's how we understand language. We have pictures of things. So when we can see something, it's a lot easier to have an idea about it. Okay? I'll give you an example. You really shouldn't be talking about the environment, because what picture do you get when I say the environment? But when you're talking to people about the environment, you should be saying the earth, the water, the trees, the air that we breathe. Because those are the things that people can relate to. So all of a sudden we can relate to our planet here. Now this is a photo they sent out of the Voyager satellite, and they decided to turn the camera on the satellite back towards the Earth. And this is time-elapse photography, basically seeing the Earth in rotation. This is the first time this was ever seen. That was, I think, back in the 70s. And now we have these satellite photos of the Earth. Now, this is the atmosphere. Now, the atmosphere goes up really high, right? It's really big, right? No. But it's really not. Because if you think about the curvature of the Earth, it's really, really thin. I mean, if you had what I would call a soccer ball, but what you would call a football, you know, just the lacquer around that ball is more or less what the atmosphere is if that ball had been the Earth. So the problem is that we're putting a lot of greenhouse pollution into this very thin layer, and this very thin layer protects us. So I don't know how many of you know about the reason that CO2 and other greenhouse gases are causing global warming. Raise your hand if you know about this. Okay, you more or less know it. Well, we're going to go through it a little bit. So basically, you have visible light and radiation, light waves of various lengths actually, hitting the atmosphere. You can see here how the atmosphere is sort of this little thin thing going around the Earth. And most is absorbed by the Earth, which is good because that makes it hot enough. Not that many of you think that it's that hot in Denmark, but still livable. And then the Earth reflects some of that energy as infrared, in an infrared wavelength. That's the wavelength we can't see. You all know what infrared light is, I guess, compared to visible light, right? Okay. And some of it gets trapped naturally by the atmosphere and is bounced back to Earth. Well, then we have the issue of carbon emissions from like smokestacks, cars, maybe the boiler in our home, in the basement, burning something. Now, this isn't, you think you're looking at CO2 here, right? But you can't see CO2. This is actually, majority of this is steam and particulates, little small particles coming out from if you're burning coal or whatever, actually those particles make the Earth cooler. What's ironic about this, by putting out all these greenhouse gases, we're actually, one part of the process is cooling the Earth. And in fact, if we stopped all the smokestacks tomorrow, and all the cars and everything else tomorrow, everything, the Earth would very quickly, within a few days, rise maybe 0.5 degrees Celsius in temperature, just because the particulates would have fallen to the ground and wouldn't be blocking sunlight. But we've never really seen CO2 until now.
In video we've used to show sources of greenhouse gas are actually cooling the Earth. They're called aerosols, any emissions carrying particles or droplets, which actually reflect the hot sunlight right back into space. It's the invisible gases that carry those reflected particles or droplets that are the greenhouse gases. What if you could see them? Say from this tailpipe. Check this out.
That's CO2.
Or from this pickup truck. The new greenhouse gas finder cameras from the FLIR company now make the invisible visible.
So, FLIR is a Swedish company, and they make gas detection cameras, among other things, for the oil and gas industry, but not for CO2. They do it for other gases. They do it for methane, which is also a greenhouse gas, but not for CO2. Because there's no reason to do it for CO2, but there will be very soon. They also create, each camera costs about $100,000. And they make also thermal imaging cameras. Those are the types that you can do in a house and see where all the heat's escaping from the house or whatever. They cost about $50,000. So I've been speaking to them and about them creating these CO2 cameras, and there will be a need for it, and I'll tell you a little about that later. But imagine if there was do you remember the BP oil spill a couple years ago or 3 years ago in the Gulf? And they had a camera undersea watching all the oil come out. Do you remember that? It was just like spewing out oil. Well, imagine if we just had a camera on a smokestack here at the power plant in Aalborg, for instance, just showing CO2 all the time. And anybody in the world can go on the web and just see CO2. Remember, what we see and experience, etc., that's how we understand things. And one of the problems with the climate crisis is it's really difficult for people to understand because we can't see what we're dealing with, what we're talking about. But this is actually it. So this just shows, the greenhouse gases that, actually the black carbon is also something, as I mentioned, when it's in the atmosphere it reflects, but when it lands on the snow, it's bad, it makes the snow melt faster. Methane is about 20, 30 times more potent as a greenhouse gas than CO2. However, it lasts less time. So it might last 10 years in the atmosphere, the CO2 lasts 100 or more years in the atmosphere, which is our problem. And I'll get back to that too. So this is an example of various, sources of greenhouse gases and CO2. Because of the rise in temperature, the permafrost is melting, and there's a lot of built-up methane. So that's escaping already. There's coal mining, and there's the plants, and etc. One of the things I don't have here is fracking, hydraulic fracturing of natural gas, which they want to do in northern Jutland, which really sucks because actually it's really bad for the water. It poisons the water. But besides that, it releases a lot of methane, and it's the oil and gas companies that are doing this, they're only liable for like 30 years. So after about 30 years, there's a big hole in the ground going down to this kind of gas formation, and sometimes the casings leak and the methane will escape. And as I said, methane is 20 or 30 times more potent as a greenhouse gas than CO2. So fracking's bad. So are you part of the whole anti-fracking thing here in the northern Jutland? Huh? Anybody here? There you go. Thank you. Skipper Gas Nighthawk.
That is what they're doing in Canada right now, right?
In the United States.
Yeah.
Canada has the tar sands, and that's another thing that's really bad. But the United States, it's horrible what's going on. And particularly right now, there's a big battle in New York State to allow it or not allow it. And it's disgusting, actually. It's immoral. But let's move on. Let's get to the other more immoral stuff here. So, if we increase the thickness of the CO2 in the atmosphere, then we'll end up reflecting even more radiation. And you don't really have to reflect that much more for the temperature to rise. So, this is an experiment that you
We
can
often
do in
hear
high
about the
school.
effects of carbon dioxide in the atmosphere. But carbon dioxide is a naturally occurring and vital component of the atmosphere. The problems occur when we have too much carbon dioxide. I've got a little experiment here to show you the effects of increased carbon dioxide. What I have here is 2 bottles, and what I've done is I've put a temperature probe in each. What I'm going to do now is introduce some more carbon dioxide into this bottle. So this bottle will be normal atmospheric air, and this bottle will be atmospheric air with a greater concentration of carbon dioxide. Now, first of all, I need to make my carbon dioxide. And carbon dioxide can be made very simply by taking sort of good old vinegar and mixing it with some bicarbonate of soda. And as I add, you can see it's all fizzing up. Now what I want to do is I want to put this hose in the bottle and capture that carbon dioxide and feed it into this bottle. So in this setup, I need to have something that represents the sun. Now, I can't bring the sun into the laboratory here, but what I'm going to do instead is use these 2 lamps. Now, at the start of the experiment, I've got about the same temperature in each of the bottles. But what I want to do is turn on the lamps and have that energy pumping into the 2 bottles, and hopefully I should get an increased temperature rise in the bottle with the carbon dioxide more than the bottle with the normal atmospheric air. So let's give it a go. So while we're waiting for the reaction to take place, what effect does carbon dioxide in the atmosphere actually have? Well, if you look at planet Earth, energy is coming in from the sun into the atmosphere. Now, some of that energy penetrates through the Earth's atmosphere and is reflected off the surface. Now, that surface reflection comes out as infrared or heat energy. Now, the carbon dioxide molecule is particularly susceptible to that heat energy, and it absorbs the radiation and then re-radiates it, and this increases the temperature of planet Earth. So this experiment has been running for a few minutes now, and we can actually start seeing the effects that the carbon dioxide has on the atmosphere. And here we have a change of about 5 degrees more in the bottle with the carbon dioxide. This is a very simple experiment showing the effects that carbon dioxide have on the atmosphere. But there are other gases that have similar effects, like methane and water vapour, and they're collectively known as the greenhouse gases. So this is a simple experiment showing the greenhouse effect, but in a bottle.
Okay? You can do this at home, actually. Certainly in a high school science lab. It's that simple. It ain't rocket science. My father's a rocket engineer. It ain't rocket science. It's really quite simple. So when you get people saying, oh, it's not this or that or whatever, it really is quite simple. We're just putting a lot of the CO2 up there, and it really does cause, you know, as you see why, the atmosphere to heat up, and that causes the oceans to heat up, and the other effects which you're going to see here. Now I'm not going to show the video here. This is actually my brother. He's a venture capitalist, lives in California. He invests in clean tech, and he's also gives these presentations. He's also trained by Almore to do this and everything. But what he's trying to show here is we're talking about parts per million when we talk about CO2. Parts per million, right? So we started out around 270 or 280 parts per million CO2 in the atmosphere around 1750. 1750 is when we started the Industrial Revolution, where we started burning lots of coal. Okay? For industrial processes, for trains, for steamships, and for factories, and for heating homes. Okay? Now, the thing is, how can it be that when you're talking about parts per million, that if you just increase it a little bit, and this is 390, we're actually about around 396 or something like that right now. We're close to 400 parts per million now. How can it be that that makes any difference? But when we're talking about CO2 and the radiation from the sun, it actually does make a difference. And this is that. But my brother did is he took ink, and this is actually diluted. This is actually 1,000 times more diluted than necessary, even just to show the difference. Because if you take, let's say, you're at a party, and you're drinking a glass of wine, okay? And you drink a glass of wine, and there's a little drop left, and you're thirsty, and someone says, "Would you like some water?" Okay? So you pour some water in the glass, and there was that little drop of wine at the bottom, and the water's a little pink, right? If it's red wine. You all experience that? It's white wine, it wouldn't be pink. Okay, so that's the same thing going on here. He puts a little drop of ink. This is without any ink. He takes a little drop of ink, and you can see the video, but a little drop of ink and comes here, and now he puts just a little bit more here, and you can see it's slightly darker. It's just slightly darker. And that little extra CO2 in the atmosphere is enough that things heat up too much. Now, the IPCC, the UN, climate organization, said back in 2007 and at COP15 that we shouldn't go over 450 parts per million. Now, we're very, very close to 400 today. But James Hansen, we'll see in a bit, he says 350 parts per million is probably where things are sustainable. In other words, we're almost 50 parts per million more than where we should be. And if any of you know, there's this organization called 350.org in the United States, which is like a popular movement to do something about global warming. So I just want to show you that, it may seem kind of ridiculous that this little amount means anything, but it does. So anyway, how long have we known about this? Well, you can go back to 1824 when a Frenchman figured out that we actually, through human activity, can change the temperature of the Earth. And then in 1896, a Swedish professor in the Journal of Science here published a paper talking about carbonic acid being CO2 on the influence of CO2 in the air upon the temperature of the ground. And he predicted that a doubling of CO2 would lead to a 5 to 6 degrees Celsius rise in temperature, which is what we believe today. And we've known about this for a long time, but we haven't done anything about it. Now, Al Gore studied under Roger Revelle, and they had an observatory in Hawaii, in the middle of the Pacific Ocean, because there's not a lot of factories or anything like that, so it's kind of pure air, and started measuring CO2 levels back in 1958 and did it every year. Now, what's going on here is, it almost looks like a lung or a heart beating, right?
Yeah.
Now, what this is that most of the vegetation in the world is north of the equator. Okay, most of it. You've got, Russia and China on the other side. And in the summer, there's a lot of vegetation, and we're sucking out more CO2, and that's where you see it get thinner. And then in the winter, where there's not a lot of leaves on the trees and everything, there's more CO2 in the atmosphere. And that's a slight up and down jump you see every year going on. But what's interesting about it is also this concept that the Earth, holistically, is like a living organism. Just like you are, just like you breathe and your heart beats, the Earth, in its own way, does the same thing. So try to take a look at this entire thing and sustainability in general in a very holistic way and see how things can be related. Now this I got to go on. This measures it up to what's happening here. They don't put a scale here, but basically the amount of CO2 in the atmosphere is rising every year. And he measured that since 1958. Now it's been going on since 1750, but he started in 1958. So in 1988, James Hansen, who just a week or two ago resigned from the Earth Institute, or from the Goddard Space Center at Columbia University in New York, because he wants to become more politically active in this, and being a government employee, an employee of NASA, he's kind of limited in what he could do. Though he has been arrested several times in front of the White House, etc., protesting this. So he testified in front of Congress. I believe Al Gore was a congressman at the time, and told we got to do something. This is 1988. Now, I don't know when people are born here, but 1988. How many years ago is that? That's
24 years.
okay. There you go. So this is the first time that this was. I mean, there had been people talking about it, but this is the first time where it became kind of political. Okay, so ever since 1988, it's been an issue. I mean, you can go to old movies and whatever from the 1990s, and people talk about global warming, whatever, just as kind of a joke. Anyway, I met him. This is at the Chabot Science Center in Oakland, California, outside San Francisco. And he gave a talk there in 2010. And my brother actually is very close to him and helps James Hansen when he writes pieces for like the New York Times or the Washington Post or whatever. And he helps him or give presentations. He gave a TED Talk last year too. My brother helped him sort of with the communications aspect. Because the problem is, this guy's a scientist. and he's not very good at communicating. And this is actually one of the main problems with the climate crisis is the people that know most about it aren't really that good about telling about it. And that's sort of what Al Gore wanted to sort of change by having this climate reality project. Now this is from last summer. Jim Hansen and some other climate scientists, they took historical data. This is not computer models. You cannot say, oh, this is all prediction. This is actually what occurred globally. And what he's showing, if you go back to like 1951 to 1980, 81 to 91, etc., that extreme temperatures during the summer have shifted to be more hot. Now, have you experienced hotter summers in the recent years?
No.
No?
Not here.
Not here. There have been some hotter summers here. It has gotten over 30 degrees Celsius in Denmark in the past several years.
But I think we have noticed a change in when the summer is because it's actually starting later and
Exactly.
lasting until August, September.
Right. And I'll get into that a little bit later with what's happened with the Arctic ice and the jet stream and everything, because that's actually changing weather patterns. And that's why, for instance, it's been kind of cold for a long period of time now, including today. There's been a couple of days it's been nice, but otherwise it's been pretty cool. So when it's very cold or it snows a lot, that could also be global warming.
That we have had the last few winters, extreme winters.
There's been a lot of snow.
Yes.
Okay, so what
And
happens?
also ultra low temperatures as well.
Well, yes, but when it snows, when it's really, really cold, the air is very dry, and there actually is very little snow or no snow. But when you're at freezing, 0 degrees, and just below that, and sometimes just a little bit above, you can get a lot of snow. And if there's a lot of moisture in the air, there'll be more snow. So when the oceans are hot, they're evaporating more moisture into the atmosphere. And then it comes over by Denmark, and it gets a little cold, and boom, you get a lot of snowfall. So this is showing computer models that if there was no human activity, this is sort of what the average temperature would be over this is a 100-year period here or something. And with the computer models, it sort of shows, that's the green here, it sort of shows that would rise with human activity, and the red are actually observed temperatures, not computer models, showing that the basic trend is following what the computers are saying. So these are the global 10 hottest years on record from 1880 to 2012, and 8 of those years are within the past 10 years, with the exception of 2002 and 1998. And actually a few of these tie in the average temperature. So it's getting hotter. So what happens? Well, glaciers melt, and you can. These are some images showing historically, going. This is a 90-year interval of an Alaskan glacier, and you can just see here, they're just melting because. It doesn't really have, it just has to be a little bit above freezing and things are going to melt. And it just has to be a little bit below. So this is actually, not everything is linear, by the way, with the climate and with just things in general. I mean, generally you might see a trend just going kind of slowly like this, but think about water. It's either ice or it's liquid, right? There's really no in between. So that's one of the things. That's why ice masses, and that's what we're going to be talking about, can collapse very quickly. Because it's either, it's like a light switch. It's either on or off. 20 years in the future, there will be so little food we're approaching 9 billion people on the planet. There will be so little food from whatever country you're from that it will start being rationed. Okay? And at some point there will be so little food that you won't even be able to go out and buy food. Now, what happens with money? What happens to money when you can't buy food for money? Money becomes worthless. It does not matter that you can buy a computer, you can buy a car. If you can't buy food, it really doesn't matter. Okay? So economies will collapse. And democracies will collapse, etc. Because when there's not a lot of food, people start fighting each other for food. Because we really need food, by the way. We need water, we need food, and we need air to breathe. Okay? So, I don't want to sound too dire, but what I do want to say is that we've been spreading a myth. And when I say we, I mean everybody working in this climate stuff. We've been talking about global warming and sea level rise, and storm surges, oh, and then there's the drought. The drought will hit us a lot sooner and affect us economically a lot sooner than the sea level rise, which will happen, by the way. But the difference is that if you live in Copenhagen or Aalborg, and there's sea level rise, and so the streets start flooding here, you just start moving your houses inland. But when there's no food around, it doesn't matter. You can't eat. Okay? So, there was an expression during Bill Clinton's first election campaign back around 1990 or so. It's the economy, stupid. In other words, the economy was the most important issue for voters. I'd say with global warming, it's the drought, stupid. You haven't really understood that the drought will affect us a lot sooner than the other things. Okay? Now, are you all depressed? Okay. Well, there's something we can do about it. So that's the nice part. Remember the rocket plane blowing up, and then my dad fixed it? Well, this could be fixed. Now, this is 2011 Tiananmen Square, Tahrir Square in Cairo, and you had the Arab Spring. The Arab Spring actually, a couple years earlier, because the Soviet Union is suffering a drought, they stopped their exports of food, and that caused world food prices to rise, and particularly hit the poor. And there had been some protests and riots in Egypt because of that. And actually global warming actually has contributed to the unrest in northern Africa. And so part of the Arab Spring is actually, maybe a small part or a larger part, indirectly certainly, due to global warming and the rise of food prices and that unrest. Okay, let's move on. Some other parts of the world. Got a lot of ice here. This is Greenland. You got ice on land, and this is ice on water in the Arctic. And polar bears aren't doing too well because there's not a lot of ice, and that's not good for them. So this just shows you a little bit what happens when things get hotter. The ice melts. But the other thing that happens is because there's not a lot of white ice on the water reflecting a lot of the rays of the sun back out into space, the water's dark and it's absorbing the energy from the sun, making the oceans hotter, also speeding up the process of the ice melting. But not only that, making the Earth hotter. So the North Pole and the South Pole, they're basically kind of little air conditioners or coolants for the Earth to kind of keep our temperature something in the middle areas where we can actually live. And now this stuff is melting, particularly north. And as I mentioned, Hurricane Sandy, they say part of the reason that it went inland the way it did and hung around so long the way it did was because of the melt of the Arctic ice that caused some weather systems just to sort of stabilize and just sort of get locked in rather than the winds blowing. So this is 1980 satellite image of the extent of the Arctic ice. And when you measure the Arctic ice, you have extent, the area, and you have the thickness, the volume, etc., etc. And this is 2007, so this is 7 years later. You see how much of it's disappearing. And, well, this is in Danish, but this is from last summer, where it was at its lowest point ever, even more than in 2007. And you can basically see the averages over the decades here, that the red line is just 2012. We're headed down this way, okay? So the trend is that by 2015, maybe 2018, there will be no Arctic ice for the first time in human history. Now, when I say human history, I'm talking 10,000 years at least. They didn't have satellites like 10,000 years ago before that, but to see. But now, some people think it's good because you'll be able to ship goods from China that way and save 4 weeks or something of sailing and I don't know what. But it's not sustainable, folks. It's just not sustainable. All right, let's look at some other places. The Antarctic. Now this is basically, most of this is on land, but a lot of this is really on islands, and there's actually the seawater is underneath this part, the western part. So the western part is the part that we're really worried about. There's been a lot of ice breakage off here, the tip here. And the problem is that these things collapse. Then all of a sudden we have, let's say, I don't know, 6 meters of sea level rise. I mean, if it all just fell in the ocean at once, and as it's melting, you know, when it melts from Greenland and it melts, I mean, more than normal, which it's doing, and in the Arctic, well, then that adds to the ocean. Whereas the Arctic ice is, you know, it's like if you have a glass of water and you put an ice cube in it, you know, that's ice that's kind of floating in there. If it melts, you know, it would be, you know, it wouldn't cause the water really to rise. Whereas if you have a full glass of water and drop an ice cube in it, then it'll overflow. Okay, so that's why the melting of the Arctic ice, which is on water, is bad in terms of reflecting the heat, but it's not causing too much in terms of sea level rise, whereas Greenland and the Antarctic is causing it. So we're seeing an increased melt, and it's actually really, really bad, and they're really worried about it collapsing. Now, Greenland is the other place where there's a lot of ice on land, and I took this picture this past summer flying to Chicago, and I took my camera over there and I pointed it out the window in the back, and I put it on zoom and I try to hold it really steady because we're an airplane. And I'm pretty sure that the front edge of this is about 200 meters high, right there. But the thing that struck me was how little snow, now this is the summer, but how little snow there was on these mountains. Because I'm used to fly in almost every summer to the United States, go back home, visit family, and I look out the window over Greenland, and when it's not all cloudy, there's really a lot of snow there still. But I noticed over the past couple of years that a lot of that snow is gone. They just see bare rock. Okay? Which is, by the way, also, you know, heating up things even more, right? They're absorbing energy now. So one of the things that's happening in Greenland is that the water's melting and it's going straight down, straight through the ice, those 4 kilometers down, straight down. And then it gets underneath the ice and it's lubricating it like oil. Now it's water, but it's making it easier for the ice to flow, to slip and slide down to the sea. So it's causing more of these glaciers to kind of move quicker. Acts as a lubricant. Now this is showing the seasonal ice melt, so like, you know, during the summer, and it would be, well, this is sort of the area where I was, and you know, maybe it's totally melted or just the top is melted. They know this by satellites. They place sensors on the ice, and then they can tell the height from satellites, and if it starts going, actually, sometimes in Iceland it goes up. If there's a lot of ice melt, the ice is so heavy that it's pushing everything down, that it's pushing the bedrock down, but when the ice melts a lot, there's less weight on the rock, and the rock starts rising. That's kind of a weird thing. But anyway, you can see here how it's increasing. But then this weird thing happened last summer. Over a 4-day period, the surface of the Greenland ice was like this, and 4 days later, it was everywhere. They had never seen that before. So the Greenlandic ice is melting, and it's bad. I mean, this is, you know, this will cause sea level rise, and then you know, things have risen some centimeters. Now, some of the first people to get hit will be like in the Maldives and other low-lying island nations. And prior to COP15 in 2009, they decided to have a cabinet meeting underwater to sort of, you know, show what they're up against. So the maps of the world will have to be redrawn, and actually in Greenland that's happening now. What's happening now? Because all this land's exposed now. Now they're talking about bringing in the Chinese to start doing mining and things like that in Greenland. I was talking back in January with one of the two, I guess there's 2 members of parliament from Greenland, and I was saying, you guys don't want to do this mining stuff, it's bad stuff, because it's just going to make things worse. Now, population we talked about a little earlier is going to be, you know, people are going to have to move when you're, you know, where are cities? Where are cities, major cities located around the world? A lot are located on water. It could be a river, but it could be on the shore. Now, why is that? Anyone know?
Trade routes.
What?
Trade routes.
Trade routes. Because if you go back, not even 200 years, how did you get around? Ships, boats. Because there were no cars, there were no trains, there were horses and horse-drawn carriages. But basically, major trade took place by sailing ship. So you'd have to be on the water and have a deep water port or a port, that was enough for a sailing ship to come to. So that's why you have major cities that are accessible to water. Historically, that's why. That's the reason. So, and populations, because of the Industrial Revolution, people moved from the country into the cities, right? So now a lot of the population is living in cities and not spread out around the countryside. And the cities are going to be hit by rising sea level, and then people are going to have to move. Now, one interesting thing, we go back to Hurricane Sandy and the New Jersey shoreline, and the shoreline along Connecticut and around New York. I'm wondering what's happened with the value of homes, certainly on the east coast of the United States, but maybe even here in Europe, because of the damage that we've seen happening with storms. So in other words, how can you sell your house now? If you have a house near the shore in New Jersey, who's going to want to buy it? Because they know in 10 years there might be another storm like that and ruin your home. In fact, I have one friend here, Tamara Rosanis, the country singer or whatever, American. She told me one of her friends, this is last week, one of her friends has a house on Cape Cod, which is outside of Boston, this very sandy area, right on the ocean. And it got battered in Hurricane Sandy, but then there was a nor'easter, another storm that came in. And these storms are becoming more frequent. And basically, the foundation of the house is now exposed, and it's about to collapse. So she sold her home for $1 to the neighbor across the street that doesn't have a very good home. They're going to lift that home and move it across the street and put it there. But basically, the home's lost. She can't. It's been condemned. She's not allowed to move back in. Okay? So this is happening all over the place. And my question is, shorefront property near the beach has traditionally been very expensive. But is it still very expensive? Is it still desirable to have a home right on the beach?
Yes.
I'm not sure.
It will be.
It will be?
Yeah, because we'll change, we'll adapt to the situation and then create floating houses that will rise and fall with the water levels into the ground.
It's the wind too and everything. But it could be. Well, good luck with that. Actually, my brother saw a prototype of that in San Francisco.
Yeah.
They were like on pontoons and everything, and and whatever. Yeah. So yeah.
You can say very shortly that humans are many things. We are very adaptable, but we are definitely not sustainable.
It's not sustainable. It's absolutely not sustainable. So from the Netherlands, you have the houseboats, right? That's where you have more houseboats. Okay, so let's talk about population growth, because what's really fueling our burning of fossil fuels is we're just a lot more people, and we desire a lot of products and everything. Okay, so we went down. We weren't a lot of people, but then all of a sudden, when 2,000 years ago, whatever, and things started rising, and we expect by again mid-century we're supposed to be up by 9 billion. Currently we're about 7 billion. So in about 30 years we're going to have another 2 billion people on the planet. Well, I don't know. I mean, this could be one of the adaptation and mitigation things as population control. More condoms. So. Anyway, we're going back to just going back here. How many people there were? So when Columbus got to Europe, got to the Americas and made life hell for the Native Americans, there were about 500 million people. When the United States got founded, there were 1 billion. At the end of World War II, 2.3 billion, and I think this says 6.8, but right now we're about 7. And then 2050 again will be over 9 billion projected. So we need more space. And we're cutting down forests. Now, forests, they absorb CO2, right? We need a lot of forests, and we're cutting them down because we need more space. Now, this is interesting because this shows actually, it's not just a question of leave it up to the market and this and that. This is a question of policy. This is Haiti. This is the Dominican Republic, right? This is Haiti. This is the Dominican Republic. Haiti. They don't care if you chop down the trees. Dominican Republic, they do care. That's the border. Policy can make a difference, right? It's not just a question of the free market and do whatever and we can't do anything. It's a question of having sustainable policies. Brazil, again, the rainforest, and then you put cattle there. Now, cattle's supposed to be really bad, except that there was one guy who gave a TED talk last month saying that we should have more cattle, but that's another story. And then we have deforestation, the Brazil, Sudan, etc., Indonesia, some other countries, Nigeria, etc. Then you got Venezuela. So these are ones that are kind of the top ones. And they often burn the forest, and burning the forest also is releasing a lot of CO2. Now, because of the drought, we've also had a lot of fires. Hurricane Sandy happened in October, and more or less at the same time there was a typhoon in the Philippines. And then in Australia, they had huge fires going on, and they had huge floods going on, and they also had a typhoon coming at the same time, like all within 1 week. So these are the big fires where lots of people died in Australia. The koala bear didn't survive, and the fireman's name is David Tree. Just a note there. But he did his best. David, good guy. This is a U.S. Air Force image of basically the red are fires, the white are just lights, the yellow is methane. I think the blue is like, I think they're fishing out in the ocean there in Japan or something like that. So, sustainability. I want to explain what sustainability is. You talk about sustainability here? You just mentioned sustainability. Okay. If you have a company and you're producing, I don't know, you're producing this so you can control your PowerPoint presentations or whatever, and it costs you $10 to produce this, and you sell it for $8, so you're losing $2 in every sale, you're going to go bankrupt, and it's not sustainable. That's sustainability. It's that simple. Sustainability is basically you do something so you can kind of keep on doing it, and everything kind of, I said, holistically, everything fits into a larger system. All right, I'm going to give you another example. I want everybody here, put your hand on the shoulder of either side of you, of the person on either side of you. Go ahead, come on. Go ahead, do it. Don't be so, whatever. Come on, you dings. Okay. Now, I'm going to tell you that if you are a company in Denmark producing things like this, okay, listen up, listen up. If you're a company in Denmark producing things like this, or any other country, whatever country you come from, and you decide that you can produce these cheaper in China. By the way, this is produced in China. So you close your factory and you move all the equipment and you move it to China because labor is a lot cheaper there. And you produce them so you get them cheaper and you ship them back so you can people can get a good price on this thing. Now, if one factory or 10 factories does this, keep holding those shoulders there. It might not make a big difference, although it's really bad for those several thousand factory workers who don't have a job anymore. Come on back there, I can see you. It's not come on, it's just your shoulder. Come on. Exercise or something. Now, if a lot of factories do this, like 75,000 in the United States do this, and you have millions of people out of work, what happens is, when you ship this thing back over to, let's say, the United States or Denmark or whatever country you're in, and people are out of work and can't afford to buy it, then it affects your sales all of a sudden. It's not sustainable. You understand that? Okay, now you put your hands up. What I'm trying to say is this. If you do something that's not sustainable, it not only will have a negative effect on other people, it will eventually hit you. Okay? Now, why did I ask you to be holding each other's shoulders there? What's that? Nothing. What did I say about the cognitive linguist, Professor George Lakoff? That we understand things through our bodies and our experiences? Well, if I just said that before and you weren't holding it, okay, David just said that. But now that you've actually held a person on either side of you, and I say that if you do something that has a bad effect on another person, it's going to affect that person and will eventually affect you, then you've experienced more in your body. So you should remember that a little bit better. So that's what I mean by sustainability. Okay? And the climate crisis, global warming, it is the ultimate issue about sustainability. Okay? We're doing things that are not sustainable. It's not compatible with life on Earth. Okay? Now, just to show you a little bit why we've gotten there, just a couple of slides here, but this used to be the way people still farm this way in some places, but otherwise we've got tractors, which means you can do a lot more with the land, and there's some issues about the way that we use the land that causes the soil to lose moisture and causes more drought. That was that TED Talk I was talking about. Let's take a look what a shovel used to look like. And now they kind of look like that. So you can do things like this. People catch fish like this, but, well, you know, you're not. Are you allowed to catch cod these days in the North Sea? I'm not quite even sure if they've allowed it again. They've gone back, but there's been overfishing, and that's because you have these huge trawler nets that can just catch millions of fish, and you know there are just not that many fish in the sea. So it's just not sustainable. And then the fishermen are out of work, and then they complain to the EU, and they say, give us some more money. And then Denmark says you have to destroy your fishing boats, which they did back in the 80s or the 90s?
80s and 90s.
Yeah. Okay. It's not sustainable.
I think they're still doing it. On a
Yeah.
As the only ones of the Europeans, almost.
No, that's the Danes. They always implement the EU rules before anyone else. Everyone else forget about it. They go, not do this. Going to war for oil is really not a good idea either. It causes loss of life. The oil's not good for our planet. It's just not really a good idea. So, then there are people that are sort of saying, you know, that global warming isn't real, or believe me, it is real. Science, there's probably not a subject that scientists are in more agreement about. There are just 2 or 3% that don't agree about the nature that's caused by humans. Now, this is interesting. Why don't people like you? I don't know. I assume all of you here believe that global warming is real and an issue and everything, but you probably have some friends and family who don't believe it. And they did a study of 928 scientific articles about climate change. Published in scientific journals, and the number that disagreed that the fact that it's basically humans causing, or greenhouse gas pollution caused by humans, that have caused the global warming, 0. Every one of those 928 articles agreed with it. Then they did a study, well, we'll go to this one here. So then you have the oil industry particularly, that isn't interested in curtailing the amount of oil, and they basically had this is the same thing they did with cigarettes back in the 60s, 70s, was basically global warming is a theory, it's not a fact. It's a fact.
And the car
It's a
industry.
fact. Okay. So, again, there are 928 articles, 0% of them were in doubt. Then they looked at 636 articles in the popular press, newspapers and magazines, for the general public. 53% were in doubt about the cause. So the scientists know it, but when the journalists start reporting it, and as late as last week, there was an article about, a scientific article was published talking about the causes of the drought in the middle of the United States, and the journalists at Reuters and AP and whatever, they misinterpreted it, and they said, scientists say that the drought is not caused by humans, about global warming and humans. But it's wrong. But it said that, CNN.com. And I said, what's that? And then I read the backstory, and they just got it wrong. So this is still happening. So people are confused. So, basically what this is saying, Upton declared author, that if you work for an oil company, it's going to be a hard time convincing you that global warming is caused by the burning of fossil fuels at your oil companies, because you're getting a salary from that company. You don't want to lose your job. So it's hard to get people to change their minds when their salary is based on doing what they're doing. Okay. By the way, I should mention I worked 2008, 2009. I worked for Maersk Oil. And they had a little climate department there, and we were talking about storing CO2 underground and all this other stuff there. Then they closed the department right after the climate crisis. They told me they might do that when I took the job. Anyway, we do actually have the technological, and we're still developing, but we have technological ways of dealing with the issue. And of course, there's wind. Yeah, there's solar. This is one of those big solar arrays where they get all the light to reflect, the energy to reflect at one point. The Vatican has solar panels on the roof. They don't believe in condoms, but they do believe in global warming. Then there's the supergrid, right? So talking a little bit about this, I'm sure this is one of the issues that you bring up here, but basically various mixes of energy, and then you have electric cars and you plug them in. I took this a couple years ago in Sweden. This is a baker with his electric car. There's a little plug right there. So he makes deliveries, usually a little electric car. There's a little sign there by the steering wheel that says, "Remember to unplug the car," because he would just drive away and pull out the plug because he can't see it down there. This has absolutely nothing to do with anything, but they make some really, really nice cakes. It might be sustainable because there's some fruit on there, I don't know. High-speed trains instead of taking the plane. I took the plane this morning. That's not good. So, I want to talk about some solutions. And I took this about 4 weeks ago, that photo. I'm going to pass this out. It kind of smells a little bit. It's about 5 of these. You can just pass it among each other and whatever. And pass them back to other rows. Maybe other row. It smells a little bit. And I'll be talking about this. This is Professor Klaus Lackner. He's from Austria, actually. He's a professor of chemistry at Columbia University. He studies sustainable energy, like making energy from CO2, for instance. And it's part of the Earth Institute, where James Hansen and the others, James Hansen was.
How many of you participated in David Major's lecture some weeks ago? David Major from Columbia University, NASA Goddard Institute with him. How many participated in that? Not that many. Okay. This is one of David's colleagues, and these are some of the guys that we are collaborating with during the program.
Okay, so this part, by the way, I know you've been sitting and listening to me talk and everything, but this I believe is the solution. Okay, I think this is going to be the solution. What Klaus Lackner, this material here, this material I'm passing around, and I have it here in a little different form, and I'll show you some pictures. But this is, they made kind of perforated or corrugated rolls of this to get more surface area. There's more of the material touching the air here. And this is to take CO2 out of the atmosphere. So here's the problem. This is what I figured out with the drought last year and Hurricane Sandy. There is too much CO2 in the atmosphere already, and it is causing the problems that we have. And the CO2 is up there for 100 years, and things are only getting worse. If we stopped all CO2 emissions tomorrow, again, all power plants and cars and planes and whatever, it will still get worse. It'll still get hotter. The drought will get worse. There will be worse fires. There will be worse hurricanes. We've passed the tipping point. So, what is the solution? What have we been, the myth that we've been talking about, James Hansen, whatever, is that we have to reduce our emissions, our future emissions. What's coming out of the smokestack? We drive an electric car based on wind power instead of gasoline, etc., etc. However, the deal is this. Hey, guy, don't. Okay. Sorry. Yeah, I didn't mean to call you guy. I don't know your name. So the problem is this, is that even if we reduce our emissions in the future, it will not make any difference. It is too late. Now, it's not saying it's too late if we don't do something about it. This material I'm passing around now what it does is when it's dry, like it is right now, when you pass it around your hand, it absorbs CO2 from the air, the ambient air, the air in this room. Okay? And when you make it wet, either by putting it in water or putting it into moist atmosphere, it releases the CO2. And I'll show you that. The reason I'm saying is this. We do need to reduce our future emissions. There's technology coming out now that you'll be able to put something on a smokestack of a power plant or a factory, or maybe even on a ship or a truck, and it will capture the CO2. And we need to do that. Yet there are other sources of CO2 that you can't capture that way. And you will have to capture it just by putting these things out there and take it out of the air. Plus, we have to go from about the 400 parts per million we're at here now, down to 350. We have to remove 50 parts per million that's currently there. It has to be removed from the system and sequestered. When I say sequestered, stored either underground in saline aquifers. I don't believe in that. I think what will happen is that we'll mineralize it. We'll turn it into a carbonate, a kind of rock, using energy, maybe from Iceland, some geothermal or whatever, some like very cheap energy for that process. And we will remove the CO2 from the atmosphere. And it will happen, by the way. And I'll tell you why this is going to happen. You all know about acid rain? Okay. What do we do about acid rain? We mandated that smokestacks had to have filters and capture sulfur. Now, you know why we did that? Well, it sounds like we did that because we knew we had a problem with acid rain. The sulfur was bad for our health, but it was also bad for the forests. The only reason we did it, ultimately, is because we could. Because the technology existed to fix the problem. If there were no way to capture sulfur from a smokestack, it would never have been mandated that we do it, and we'd still have a problem with acid rain. What's being developed right now are systems to take CO2 out of the ambient air around us, and systems to take CO2 out of a smokestack, which is more efficient. There are ways of doing it now, but it's very expensive and very cumbersome and uses a lot of extra energy, a lot of extra coal to run the process. There's new processes coming out now that I think will bring it down to about $15 a ton CO2 captured. Then you have to maybe transport and store it and everything. Otherwise, they're talking about coming from $600 a ton maybe to $60. We're going to bring down about $15. This method might bring it about to about $25. But once you could do that, then you actually, like the European the emissions trading system, which is collapsing right now because the credits aren't worth anything, basically, rather than just trading to say I'm allowed to pollute, you'll be basically paying money into the system to physically remove CO2 from the atmosphere. So let's look at this stuff. This is some test apparatus. This was at this time it was testing the effective temperature on this material, how well it was. Now this is different iterations. So you have the little flat one I'm passing around. These are the little ones I just showed you. They have one that looks a little bit like a shag carpet, one that looks like a feather duster or a toilet brush. Now again, this is all really to get more surface area, more of it in contact with the air. And this is taken about 2.5 weeks ago, this photo. And they built it, they have a little greenhouse and a lot of plants in here. And there's a little monitor that shows how much moisture is in the air and how much CO2. This is Buzz Lacker and Alan Wright, his assistant. So you can see the plants. These are just potted plants. The reason it's this color is they're using this kind of light for the greenhouse. But you see that little roll there? That's this material. It's actually a little slightly bigger one. It's about this big of this here. And it's the same material that I'm passing around. And what they do is they have it out in the dry air, and then they put it here. They didn't even, the first time I saw this, they actually put it in a beaker of water, made it wet, put it in there. And I saw how the CO2 in the greenhouse, how it rose. But here, because they have so many plants that are in little basins with water, there's so much moisture in there anyway, they just put it in there. And here you can see the start of the experiment. You have the moisture and you have the CO2, and this is about 360 parts per million here. And then after about 20 minutes or so, it's risen to about 520 parts per million. And then what you're seeing is a trend here. I didn't want to wait long. I had to get to a meeting and stuff like that. So, but basically, you'll see the line start going down. So you put this in there in the greenhouse, and you see a lot of the CO2 rises, but then it goes down again. Does anyone know why? Any biologists here? Anyone who took biology in high school or middle school? There are plants there that are sucking up the CO2. So basically the CO2 is in there, and then you see it start to diminish because the plants start taking CO2, and then it just flattens out again. Then you put a new one in there. But what this shows is it works. It shows it's actually releasing CO2. Now, the idea is, for this particular technology, take something like, looks like a shipping container, and you have this is that material you've got there, kind of going around in filters, and you have a compressor, and you put it down, you take one filter at a time, it goes around maybe once an hour, and you make it moist, and it releases CO2, and you compress the CO2. You have to do something with the CO2. So there are two issues with this one. To compress it sufficiently, so you can do something with it, and then what do you do with it, with the CO2? Now, there are carbon neutral things. You can make methanol, which is a kind of a fuel, and other things. You can actually create energy with the CO2. You can use the CO2 directly in real greenhouses from the Netherlands or Denmark or other countries, you know, for tomatoes and other things. And you can actually, the greenhouse will actually pay you for that CO2 stream to go in there. But basically, we need to remove the CO2 from the atmosphere, and when the technology exists, it will be mandated. There's another benefit, because how many of these do we have to build? These are designed, and currently they're designed to take 1 ton of CO2 a day out of the atmosphere. We release 90 million tons a day. I figure we have to build about 150 million of these, probably 15 million a year over 10 years. Each one lasts about 10 years, so you keep on building new ones. And I figured that about one job will be created for every 4 of these. And these cost about $25,000 a piece. So for, let's say, every $100,000 you create a new job, that's like 3.5 million jobs. So politicians, they don't care about doing anything about global warming, but they do want to create jobs. Now, where would you put these jobs? Anyone from Greece? Home. You're not, why are you in Greece right now? So, how about if you take a shipyard in Greece and you create 10,000 jobs or 100,000 jobs in Greece? Or Portugal, or Italy, or Spain, where the economy isn't all that good, and you create jobs that help the economy, which then helps the entire EU, which then helps the United States, because a lot of the United States economy is dependent on the European economy. You can put them in old car factories in Detroit. We build about 60 million passenger vehicles a year worldwide, in China, Europe, the United States. We used to build about 80 million before the financial crisis. So there are a lot of unemployed people in the car industry. So put them there. You can build them anywhere. You can build them in West Virginia, where there are a lot of coal miners, and you don't want them digging for coal anymore. So the point is this. This is not the type of thing that a typical venture capitalist will look like and say, hey, there's a business model. But this will happen. It will happen just like removing the sulfur from acid rain. It will happen just like we have to wear a seatbelt in a car. Because in the mid-1960s, cars didn't even have seatbelts. Right? But then they realized a lot of people were dying. There were seatbelts, and they mandated that car manufacturers have to put, it costs them money, but you have to put seatbelts in the cars. And then they have laws they have to use a seatbelt. So, this is one of the solutions. There are others. I could talk about other things about how appliance manufacturers, and this we should probably talk about this as something for, but appliance manufacturers should be making appliances that use little energy that you have to plug into the wall. Use a lot of solar, a lot of wind, a lot of autonomous energy, basically. And develop that for developing countries like, you know, India and Africa, but then take that same technology and put it into stoves and laundry machines, whatever, in Europe and the United States. I'll give you an example. Climate Healers, based out of California, and there was a project in India. In India, people were chopping down trees to burn the wood to cook food. And so there were no more trees on the hills, and all the grass, everything eroded. It was all just mud. So they wanted them to stop that, but they had to give them a way to cook. So they gave them these solar cookers, like a big parable, you know, reflects the sunlight, gets real hot, and they could cook their food. And then they gave them a cell phone, a mobile phone, because that would only charge when your solar cooker was running. And they gave them 3 minutes. So there's an incentive to use the solar cooker and stop chopping down the trees. And within about 2 years, the trees had grass again, and the trees started growing on the hills. But people complain about the solar cooker because I can only use it during the daytime, and I have to cook food at night, and I have to get up early in the morning when the sun hasn't risen and cook breakfast for the family. So they said, well, come up with a solution. They took basically soda cans, like a Coca-Cola can or something, filled it with sand, and heated that up. And actually, they stored enough energy in that they could cook dinner, and there's still enough energy the next morning to cook breakfast. Now, imagine if you did that and you took that technology and then you're using it in Aalborg or Athens or New York. Right? Like, why shouldn't we also be using those same ways of doing it? Now, if you do that, you reduce the demand for having the power plants. There'll still have to be power plants, but they won't have to be as many and they won't have to be burning as much fuel, fossil fuel. So, see how that all kind of works? This is the type of stuff you could be working on. The world will not be destroyed by those who do evil, but by those who watch them without doing anything. And you have to do something. Right? We all have to do something. By the way, this photo here, that's my mom. Literally. That's my mom, 4 years old, on the shoulders of Albert Einstein. So, I feel that if there's something that's broken, something needs to be fixed, if you have a rocket plane that blows up and it needs to be fixed, then you fix it. Okay? So we have all this stuff going on, and I hope in your studies and in your future life and everything that you think about these things, how we move on. Now, I want to say something else, that I'm with this thing called Democrats Abroad. It's the American Democratic Party outside the U.S., and I was, until 2 or 3 weeks ago, I was the chair of the Denmark Committee, but I'm not allowed to be chair for more than 2 terms at a time. Anyway, in 2011, we went to Washington and we knocked on the doors of Congress to speak to senators and congressmen about issues affecting Americans living overseas. And I met John Lewis. Now, John Lewis, I'm going to see how much time I got. Okay, got enough time here. John Lewis is he's a congressman now from Georgia, but in the early 1960s, he was working in the civil rights movement because blacks, particularly in the South, were not allowed to vote. They couldn't vote because they were black. The law said they should be allowed to vote, but the way that the local election rules and everything were, blacks could not vote, so they fought for that. He and also just the rights to when you got to a bus station, there would be a waiting room for whites and a waiting room for blacks, just like in South Africa. And he was one of the original 13 Freedom Riders that rode on a bus throughout the South as blacks, and they'd go into a waiting room and they'd get beaten. Okay? So we had this meeting in his office. These are people from Democrats Abroad. And he started showing us from March of 1965. Okay? I should mention, John Lewis is the last survivor of the 10 people who spoke in Washington in 1963 when Martin Luther King gave his I Have a Dream speech. Okay? He was just around 20 years old at the time. This is in here, and there's a preacher, a priest here, and they're marching, and they come over to this bridge in Selma, and he said that the police chief here said that they should stop, and then the priest said, can we kneel down to pray? And they started kneeling down to pray, and then the police started beating them. And this is an iconic photo of John Lewis here with a policeman with a police baton bashing him over the head, and he still has a dent in his head here. They fractured his skull. He almost died. And this is the first time he's been beaten. But he believed enough in this to fight for it. Okay? Now, it's going to take like 5 minutes, but I don't know if I have time for that. A video of John Lewis speaking this past September. But I'll just say, he was at the Democratic Convention, and the Republicans wanted photo ID for people to vote and all these other things. It was basically designed for blacks and young people and old people and people who would tend to vote Democratic not to be able to vote. And he was fighting against those things 50 years later. But by the way, because of this one photo and because of what he did and the other people did and because of several other incidents that happened just around that time, that was in March of 1965. In August, the U.S. Congress passed the Voting Rights Act, which actually currently is being debated now in the Supreme Court, right now from a county in Alabama where this took place. But anyway, this is, I'm just saying, you can have some passion and conviction in what you believe in. So it's not just technology, it's not just issues, it's a question of you. You're the change. Okay? This is the speech. I'm not going to do it here. We'll go on. You should see the speech. But talking about passion and conviction, the United States, basically within about an 8-year period, when John Kennedy said, let's send somebody to the moon, they built a rocket to send somebody to the moon. And by the way, I said I know a lot about space. It's really, really difficult because there's this thing called gravity, right? So if you throw something up in the air, it kind of falls, and if you have something weighing millions of pounds or kilos or whatever, and trying to send it takes a lot of energy, and then you have to get them to land and all this stuff. And one of my step-uncles was the project manager on the lunar module, and he said, we thought the whole thing was going to crash, actually. They didn't think the thing was going to happen. But basically, if you have some conviction, and you have some technology, and you have some ability, you have some thought, a vision of where you want to go, you know, it is possible. So again, this is a little bit later on, a satellite going to Mercury, taking a photo of the Earth. And then that Voyager one that we saw in the beginning, it was about 4 billion miles away from Earth, and they decided to turn the camera back to Earth. That one pixel there is Earth. That one pixel is what we're on right now. That's all it is. In the big scheme of things, it's nothing. It's all we got.
Is it Voyager who is outside our solar system now?
Well, they're debating whether or not it's outside or not.
Okay, so
it's a little bit of a debate. So again, this is it. And that's my presentation. There you go. I do want to collect those small material pieces. I have about 5 of them, so please, you can pass them out to the side. Oh, they're right there? Great, thank you. Yeah? Questions, exactly.
Any questions for David? Based on the presentation, but I guess you'll be here all day as well, so there'll be ample time also to talk with you. But otherwise, questions? Yeah, Mette?
You addressed already the problem that I think many of us suffer from, the skeptical ones, and the ones who will not want to believe that this is actually a fact. Another problem, another challenge I think that we face is very often we say, well, Denmark is a very, very small country. How can anything that we do here in Denmark at all have any effect?
Vestas,
Yeah.
Siemens, which is another, the German company is based in Denmark. You mentioned, in Hansholm, there's this wave energy thing that's going nowhere, but that actually should be used. There are district heating. 30% of the population of Copenhagen ride their bikes to work or school every day. I mean, there's a million. This country has to be one of the most sustainable in the world in terms of lifestyle. Just a district heat. You know what district heating is? Basically, the excess heat from the power plant that otherwise would go into the water up in the air, that they heat up, superheat up water under pressure, so it gets really, really hot, and they put it through pipes through the city, and then it goes into buildings like this one and heats the building. So they're reusing, even though they're burning coal, which is really bad, at least they're getting more energy out of that coal than you would normally. So I don't know, does that answer your question? I think this is a great place.
No, not really, because actually this is the starting point. We're already doing this. So if I say to my politicians, you need to be more bold. You need to make bold decisions, make radical changes, perhaps in small steps. I would say, well, what does it matter if we do it, if they don't do it in France, if they don't do it in the US, if they don't do it in China? Because Denmark is such a small country.
You're setting an example.
Exactly.
No, seriously, I mean...
But it's more than that. I mean, you have to think solution-oriented. You have to convince not just the politicians, but also the businesses, the market, that we are delivering the solutions. Danfoss, Grundfos, all these, Vestas, we are delivering solutions. Vestas are not delivering windmills, they're delivering clean energy. Danfoss not just delivering whatever
sensors,
yeah. So we are delivering solutions, not just in Denmark, but also to other countries, because we are, setting an example first, having the home market. That's where Vestas and the clean energy and whatnot sort of got into effect. So if you don't have the home market, it's going to be difficult. because then you have to compete on a global market where you may not have the home field advantage. So creating that home market advantage and creating the solutions that will work here and having that field to play in, and then go abroad. Grundfos, I mean, the students in the environmental management group, I know you've heard this before, but the Grundfos pump, alpha pump, is a great example. As you said...
Remember my sister's house with the tree on it? What do they have in the basement? Grundfos water pump. That's using a lot less energy than they would otherwise.
It will be mandated when the solution is there. Grundfos pump is an example.
Yeah.
They had the market.
Right. Now I'm in communications, right? So it has to be communicated. Scientists and engineers aren't generally the right people to communicate things. But you have to, politicians actually, some, like Al Gore and others, can be good at communicating. We also have to focus on what the issue is. So in other words, some of the solutions are this mitigation of what's coming, what we're going to be emitting. But as I said, we also have to do something in what's already up there. And we have to sort of change our lifestyle. But you remember I mentioned about the sand in the soda can and stuff? I mean, is that going to affect your lifestyle, that you're getting heat on your stove from that rather than you turn up, you have an electric thing going on? I mean, does it really make a difference? It might make a little bit of difference how you make the food, but wow, there'll still be food around to make, okay? So it's these type of things, and they have to be promoted. Denmark is, the Danish language is a passive language, right? You have passive constructions that aren't as active. The United States says, this is the best in the world, and what was Carlsberg? They came up with it was actually, kind of pointing, probably the best beer in the world. That is kind of very modest and everything. And it has to be promoted better, but also people have to understand it better. The politicians have to understand it better. They really don't understand it. Most people don't get it. As I said, if you go back just to the end of 2011, even people like James Hansen and others didn't, I mean, this is really serious. So our solutions have to be a lot more directed to solving the problem, understanding what the problem is. And then there's these other solutions that along the way are also necessary. So like people riding bicycles or whatever, or taking the train instead of the plane, but then the trains have to be there. And they have to be running often. And they have to be cheaper than the plane and things like that. And that could be a policy decision, for instance, right? So anyway, but we could talk afterwards, certainly. Yeah.
No, I just would like to maybe help you a little bit to answer the question the woman behind me asked, because normally here in Europe, we have always learned that what happens in America happens here 10 years after. But especially this thing about the climate change and the windmills and the solar energy. I remember when I was going to school, when I was in 10th grade in 1985 and 6, there was nothing about climate here in Denmark. We didn't hear anything so much about it in the media. It actually started in the beginning of the 90s, mid-90s about that. When it actually, and then it's simply just changed. And one of the things that I know Bill Clinton is, when he's making lectures around the world, he actually says to people, if you want to see how society should be done, look at Denmark, because we are actually quite sustainable and we were early with green energy. And here is actually an example where a small country showed the rest of the world how to be more energy friendly and ecological friendly. And he actually set the example, making especially Obama after these storms and what happens in natural catastrophes happened, that he said we have to think more sustainable. And I think that he looked very much, maybe not to Denmark, but especially to Europe.
Right. No, Dave mentioned Denmark only on one occasion. Bill Clinton was coming in after he had been president for giving a talk here, and as he's coming in over Copenhagen Airport, he saw the line of windmills outside Copenhagen Harbor, and that's what he mentioned. And he understands, and he's mentioned also in talk shows and things like that. Denmark is a great example. And what's nice about it is such a small country is that you actually can get things done here. You can actually do things. And also, this is a very project-based kind of society. Smaller companies, people work in project teams, and that's really what's necessary to get things going. So I think it's an excellent example, and more can be done. And if you take the bike example, they talk about Copenhagenizing. It was Gell Architects in Copenhagen that were the consultants for New York City to put the bike paths in New York City. So, and I was talking to the guy, he's actually an American, I was talking to him about the project manager. He says, do you know why the bike paths are so wide? Like you go to like 9th Avenue in New York, they have these really wide bike paths, really wide. I said, much wider than you see in Denmark. In Denmark they're like this, but here they're like, like a car lane. I said, what was that about? He said, they didn't have snow plows that were narrow enough. So in Denmark, they make snow plows that only plow the bicycle paths, right? You see them in Copenhagen. I don't know if you have them here in Aalborg, but you certainly see these little narrow things, you know, guys driving around this whole thing, you know? But they don't have that in New York, so they had to make the bike paths that much wider just for the snow plows during the winter to be able to plow the bike paths. So it was just kind of a little funny story about, well, I guess I don't know if it's an adaptation, but anyway. But seriously, Denmark has a lot of knowledge and has a lot of actual products and things like that. So it'd be interesting to talk about how to promote that more. But certainly on the world stage, this is looked at as one of the places, perhaps the place that's most sustainable. And you have like the island of Samsø, for instance, which is exporting energy and things like that.
We are currently using 25% of our energies consumption is from windmill energy.
Right.
And about 20% of these mills are placed here in North Jutland.
Northern Jutland. And actually the reason, this is a policy thing, so I don't know, the reason Denmark is so good with the windmills is there was so much wind in, not too far from here. You drive about an hour and a half from Aalborg, you'll get to Thy, that region there, and it has a lot of the wind coming off of the North Sea. It's very windy, and they had made a policy change. They said to people, if you build a windmill, you can sell your electricity back into the grid and make money. So all these farmers, because Danish farmers in Jutland particularly, they really like making money, and they started building these windmills. And you can actually go around, I went on a tour, and there were these windmills going back from like the early 80s and then going all the way up to modern ones. And you could still see some of the old ones and the more efficient newer ones. We went inside of one in the tower and looked up. I could have taken some pictures here of that. So actually that was a policy. It was because of that policy change that companies such as Vestas, which was just, what were they building? They were building steel something or other, but it wasn't windmill. And they started building these things. And there were all these little companies, and then they all kind of merged together into just a few very large companies. That's a policy thing that actually caused the technology to be developed. Okay.
Thank you very much once again.